This video demo focuses on the Advanced Memory Protection layer. For the demo, we will be using Metasploit to launch an exploit named MS1103IE Cascading Style Sheet Import. We wanted to isolate as best as possible the Advanced Memory Protection layer. To this end, the systems under attack are unpatched, so the underlying vulnerability for the exploit exists. If we look to the right, there's a description of the exploit itself, and it's noted that the exploit is a type of memory corruption vulnerability. In particular, it is a use after free exploit. Of great interest, however, is that the exploit bypasses DEP and ASLR, so those protection layers are not available to the systems in the demo. In addition, the systems in the demo do not utilize Microsoft's EMIT, so no protection is afforded there. So the exploit should reach the point of memory injection. This exploit will use a payload which is delivered via reflective DLL injection. The payload will be the Meterpreter reverse TCP payload, which will establish a TCP connection between the target and the attacker. Protection against memory injection is then a viable defense, and since the payload is a reflective DLL injection, the relevant protection layer is provided by the advanced memory protection capabilities within Lumension application control. As the attack does not write to disk, AV and traditional application control will not offer a relevant layer of defense. Okay, so let's take a look at our demo environment. On the left, we have a couple of Windows 7 machines. Both are attached to an Active Directory server. And on the right, we're lucky enough to have an attacker in our network as well. And that attacker is running a distribution called Kali Linux. And Kali is the Hindu goddess of destruction, and it's a rather appropriate name for all that that distribution brings with it. So, as noted in the slides, we will be using Metasploit to launch an exploit. And we're going to take advantage of some of the things that Kali brings with it. There's a ton of stuff here, and in particular, we're going to use a graphical front end for Metasploit called Armitage. It just makes things a little bit easier to see, and it provides a little bit of additional functionality. So we'll go ahead and get that started, and we'll need to start the Metasploit server, and that will take a little bit. So let's go ahead and just look and see that these systems are the same. And so the upper unprotected system is Windows 7 Enterprise, 64-bit operating system. And again, Windows Update is not being applied, so the system would be vulnerable. And the lower system, same thing. System, Windows 7 Enterprise. It is also 64-bit, and updates are not being applied. However, this system, this little blue logo down there, is an indication that the Lumension agent is present on the system. So let's take a look at what is installed. And the Lumension agent is modular, so you can deploy and enable different depth and defense layers. And one of the modules that is not installed for this demo, as we noted, is the patch management layer. Antivirus is installed, however, it's not going to do much to protect against this exploit. And application control is installed and enabled, and we'll take a quick look at application control. So the service is installed and up. The system is in lockdown. That is, the agent is actively looking at executables that are launched by the system to see if they're present on the whitelist and allowed or blocked. And there's a set of application policies that are applied. In particular interest is the Advanced Memory Protection policy, and we'll look at that much later in the video. So Metasploit's finished launching, so let's go ahead and look at it just to see that it is Metasploit. I don't know, I always like the banners in Metasploit. So yes, it's Metasploit. There's a whole ton of exploits available, a lot of payloads and encoders and a whole bunch of stuff. So we're going to use the exploit that was a Windows exploit. It was a exploit intended for the browser, and in particular it was the cascading style sheet exploit. And we are actually going to use a copy of that exploit. So there were a couple modifications made, not to the core of the exploit, but just for the sake of demo purposes, so this shows a little bit better. And so that's the one that we talked about. It is a memory corruption vulnerability, so a memory exploit. And we bypass quickly that protection layer provided by DEP and ASLR. And the payload that's being delivered is that reflective DLL injection payload. And we want to go ahead and serve that up on a standard port, so port 80, and we'll make the URL straightforward, and we'll just go ahead and launch that. And yes, so anybody who accesses this web server, which is the address of this machine, 10.2.11.55.16 at port 80. Anybody who accesses that is going to be nicely served up an exploit just to verify or to show, yes, this is the .16 machine, and that's where I'm serving up the exploit from. And so let's go ahead then, and there are several ways that user could encounter this site. Could be a link from another site. We're going to look at it as if it were a phishing exploit. So I go ahead and launch my browser. Hopefully we'll connect here sooner or later. And there we are. And I set up a little link to checking email. Could be personal, could be corporate. Maybe double click, that's better. And there's my inbox, and congratulations, I am a winner. It's always good to hear you're a winner. And let's go ahead and see what that is. Oh, promotions at Dunkin' Bucks. Dunkin' Bucks is my favorite. Dear loyal customer, I'm glad to see I've been protected from some part of this message, but thank you for your recent purchase. You've won a free cup of coffee. Okay. I got to get the coupon code by June 1st. Oh, and at the Dunkin' Bucks. So, okay, I'm just going to see the rest of the content there. Maybe I'll see the rest of the content. Ah, there they are. Oh, that's the Dunkin' Bucks logo. Everything's good. I love Dunkin' Bucks. Get my free coffee. Here's your free cup of Joe. All prizes have been awarded in a lot of fine print. Well, that's a rotten contest. So I don't know what it's doing now. Let's get rid of that. No, it's not. I didn't win the coffee, and I don't know what that happened there. But I'm going to go back to, looking at the NCAAs probably. See how March Madness is going. And I'm just going to go on with, with my day, because everything's fine. I'm disappointed I didn't get the coffee, but, I'm fine. But from the Metasploit perspective, obviously things are a little bit different. So we'll go back and look at where we left off. So the server was there. It started, we got a request, and we basically sent the exploit down. And there was a Meterpreter session open, which certainly looks like a TCP connection from a given port on this machine 16 to that machine, which is 13 at a high port. And looks like we did a couple of things. We were running in the Internet Explorer process, but we basically migrated, we spawned and migrated to Notepad. And this exploit actually opens up a couple of sessions. From this perspective over here, I have a couple of open sessions, and I'll make one of them interactive just to show that, classically we've got control. And who was it that logged on? What information about the system? Yeah, it's this Windows 7 64-bit build. Computer name Jast, and probably the easiest thing to show control nicely. Oh yes, we can get a screenshot of everything the guy's looking at. So that clearly looks like I'm in control, besides this nice red box over there that looks pretty ominous. So if we look at Process Explorer on the user's machine, of course he typically wouldn't have this running, but sure enough there are a couple of Notepad processes running on the system that the malware has migrated to that don't show up in the taskbar. So unbeknownst to him, his system's under full control at this point. So now the interpreter session, we're still serving up exploits on that port. So let's see what happens with a protected system. And we'll go ahead and do the same thing. This is K9. K9s are usually a little better protected with sharper teeth. But K9 got the same we're a winner message from Duncan Bucks, and oh, I trust Duncan Bucks. Yeah, let me see the full message. A loyal customer, perch, thank you for, oh, free coffee, fantastic, let me do that. Okay, free cup of, oh, something, that was quick, but then, it looked like it said I didn't win, didn't it? So I'm just going to go on, and from the Metasploit perspective, it looks like we served up the same exploit and started sending stuff, but I don't see that I've taken control over that machine. If we look at the sessions, well, the only sessions that exist are between .16 and .13. So the session with any other machine wasn't done. And if we go ahead and look at Process Explorer over here, I don't see any Notepad EXEs launched. And sure enough, so that was the effectiveness of the advanced memory protection blocking that injection. And the exploit still happened. You know, we got presented with that browser information, but the system did not get compromised. And just to take a quick look, we'll take a quick look just to see how easy it is to set up memory protection. So to do that, we'll have to go to the Lumension server machine, which due to lack of use has locked me out here. And hopefully I typed that right. So there's the console, so the overall view of Lumension systems. We don't have a whole lot of systems in this test network. So let's go ahead and take a look at the endpoints. And the system in question was SEC, and sure enough, LAC is installed, LAV is installed. And go ahead and look at the application control policies. Well, there's a couple of policies that have been applied. There's a memory injection policy and lockdown policy. And so if we want to take a look at the policies, we can look from here. And we'll take a look at the memory protection policy that's been applied. So we'll just go ahead and review it. So memory injection policy, we are enforcing memory injection protection. We are logging. It gets enabled immediately when the policy was first applied. And we can also set up policy exceptions to exclude certain processes if necessary. And we then simply apply that policy to any agents that or any systems that are relevant. So it's relatively simple to set up, not a complicated configuration. And that concludes our demo of advanced memory protection. Thank you.